Okay, so let's continue. Alright, we have example 9 and example 10. Okay, so now let's see what are the difference between two independent samples. Okay, you have to determine when you reading the question, you have to determine whether it is independent or dependent. Okay, sample population. Okay, okay. So example 9, to estimate the difference between the weight of male and female student, we select two samples, one from male student population and another from female student population. So let's see whether male and female student they have relationship or not. Okay, so if there is no relationship between the first population and the second population, it seems that example 9 is cases where we have two um, two independent sample, population or sample. Okay, so for example 10, suppose we want to estimate the difference in the mean weight of all participants before and after a weight loss program. Okay, to accomplish this, suppose we take a sample of 40 participants and measure their weight before and after the completion of the program. Okay, since that the same participant were measured, okay, the first population or the first samples and the second samples have relationship because it is the same sampling unit, kan? So we say that it is dependent. Okay, so this for this example it is dependent. Okay, and if you take a look at this, okay, refer to your list of formula that you printed. Okay, depending on situation, we will have different formula so that the interval estimation, the first is we have to determine whether it is independent or dependent. The sample is independent or dependent, and then the next thing that you need to okay, this is the first decision that you need to do while reading the information. And next things that you need to decide is, okay, whether the sigma or sigma square is known, or okay, sigma or sigma square is unknown. Okay, so this is the second thing that you need to decide. Alright, how do you know whether the sigma or sigma square is known or unknown? Okay, you read the question, whether the question give us the information of population standard deviation or variance. Okay, if not, so we assume that the sigma or sigma square is unknown. Okay, the next thing that you need to decide, if it's, let's say that you decide the sigma or sigma square is unknown. Okay, let's say that this is our decision. The next things that you need to decide is, okay, whether number 3, suppose that this is the route that you choose. The third decision that you need to decide is whether, okay, the sigma or the standard deviation is equal or unequal. Okay, it means that they will state, okay, in the question whether the group have equal variances or unequal variances. Okay, variance and standard deviation is interchangeable because you get variance from standard deviation information, and likewise, okay, you can get variance by using standard deviation information. Okay, so depending on this case, you will have different formula. Okay, so let's take a look at the first example where the sigma or sigma square is known. Okay, let's take a look at the first example. Okay. Okay, the first is confidence interval for difference between two mean is known. The sigma square and sigma is known. And then we have confidence interval for difference between two means, sigma square and sigma is unknown. Alright. For the second part, I will give you another video, another part of recording session. Alright. So let's take a look at this one first. Okay, confidence interval for difference between two means. Okay, different mean between two mean, it means that we want to see whether the mu1 minus mu2. Okay, mu1. Okay, mu1 minus mu2. Okay. Okay, mu1 minus mu2. Alright. And this is the assumption. The sample is random sample. The population is normal distributed. The sigma square or sigma for the population unknown. And the concept of confidence level is still the same. Means that we have alpha 0.1, 0.05, okay, 0.01 or others lah. Okay, but the alpha value is this is the common one lah. Okay, the value yang the given by question is this is the common one. Alright. And when the cases arise, okay, you have to find the z value, the z value, where the z value is based on z distribution. Means that we will use the statistical tables in Z. Right. So let's take a look at the formula. So formula just still since that we have two groups, so different group will have different x bar lah. Okay, the first group they will have x bar 1, the second group they will have x bar 2. And this particular value you need to find it using table. Okay, and also since that the variant is known, okay, so we will transfer this into this formula lah. Okay, and remember the same population, if you use as example Archis and FSG, okay, Archis student as number 1, FSG student as number 2. So means that the number for the symbol, the subscript must be the same. Kalau Archis 1, all of the symbols means that x bar from Archis. Okay, and 1, how many sample is Archis student, and sigma square 1 means that the population Archis punya information. Okay, while for FSG, since that Archis dah number 1, so FSG is number 2, so the information is number 2. Okay, the subscript is 2 lah, x bar 2, okay, sigma square 2 and n2. Okay, so this the subscript here means that since now we have two population, so you have to determine which one 1, which one 2. Okay, so let's take a look at the examples. Okay, a study was conducted with two types of engine. So we have A and B. Okay, so you can use 1 and 2, or you can use A and B. Okay, so suppose that I use 1 and 2 kan. Okay, engine A is 1, so I have to distinguish the information. What are the information? And since that this is interval estimation for between two different mean, so this is the symbol actually. Okay, we want to find the mu A minus mu B. Okay, and they say that assume that the population standard deviation, so this is the information given to us. Okay, this is information given to us. Okay, assume that the population of standard deviation are 8 and 6 for engine A and B. So means that this is example where the standard deviation is okay, both standard deviation 1 and standard deviation 2 is known. Since that this is known, we know we will use Z distribution to calculate the confidence intervals. Okay, to calculate the confidence intervals. Alright, and for this particular formula, okay, you refer back to your list of formula. Okay, so we will use this lah. The formula that we will use is x bar 1 minus x bar 2, okay, plus minus z alpha over 2, okay, square root sigma square 1 over n1, okay, okay, plus nampak tu, plus, okay, plus, okay, sigma 2 square over n2, okay, you square root all of this. Alright, now our task is you need to determine the information to transfer it into the formula. Okay, so let's say engine A is 1, engine B is 2. So you need to find first what is the information of x bar 1. Okay, in calculator, okay, let's say we take a look at the question again. Okay, a study was conducted in which two types of engines A and B were compared. Gas mileage in kilometers per liter was measured. 50 experiments were conducted using engine type A. So means that these 50 experiments, okay, is the samples. So for engine A, okay, the first information given to us is actually N. Okay, N equals to 50. Okay. While for type B, they are doing 75 experiments. So for engine B, this is 75. Okay, if you have different numbers of N, okay, N is means that your samples, your observation, it is one of the hint lah. Okay, we actually use independent sample. Okay, independent. So this case is for independent. Okay, if you confusing, okay, you take a look at this map again. You take a look at this map again. Okay, you take a look at this map again. The first thing that you need to decide, okay, whether the question give you independent or dependent question. How do you know whether it is independent and dependent? You have to understand this definition. Okay, you have to understand this definition. Okay, and tips, the hint that first that you can get from this information from the example 11 is they have different numbers of n. So this is one of example where it is for independent cases lah. Okay, next, what are the information given to us? The gasoline used and another condition will held constant. The average gas mileage for engine A was 42 miles. It means that this 42 is from engine A. Okay, from engine A, and based on this observation N50 ni, N50 they calculate. Okay, they calculate, and then they get 42. So this is x bar lah. Okay, x bar equals to 42 x bar. Okay, since that we have A and B, we have to put the subscript number lah. N1 x bar 1. So this is N2 x bar 2. Okay, and the average for engine B was 36. Okay, and 36. Okay, now they ask us to find 96 confidence intervals. So 96%, okay, 100% minus 66%, we got 4%. We got 4%, and transfer this into decimal point. So means that 4% is equals to 0.04. Okay, so means your alpha is 0.04. Now you have to find Z. Okay, 0.04 divided by 2 is Z 0.02. Okay, and you find this by using your table. Okay, so let's take a look at our table. Okay, our table. Where is our table? Table. Table. Here. Okay. Okay. Since that it is Z, okay, let's take a look at this table. Okay, Z 0.02. Okay, so this is the value that we will use lah. Okay, 2.0537. Okay, 2.0537. So this is based on table. Okay, now since that we already have the information here, so transfer this into your formula. Okay, I will use another ink. Okay, so x bar 1 is 42 minus 36 plus minus 2.0537 times square root of assume that the population standard deviation are 8 and 6. So means that another information from this NGNA is sigma. Standard deviation is sigma is 8. Sigma 1 is 8. Okay, sigma 2 is 6. Okay, sigma 2 is 6. So when we transfer to the information, okay, you need variant. So what you do is 8 square divide by 50 plus 6 square divide by 75. Okay, so this is the thing that you need to calculate lah. Okay, so let's wait. I want to get my calculator. Okay, so let's calculate this one. Okay, 42 minus 36. Okay, so you will get 6. Okay, plus minus 2.0537 times, okay, this is square root so you will get square root of 1.76. So you further do, you will get plus minus 2.0537 times square root of 1.76. You will get 2.7245. Alright, so when we do the mu bar minus mu 2, okay, the confidence interval, the last answer here is 6 minus 2.7245 and 6 plus 2.7245 okay. 2.7245. Okay, and you will get the answer. Okay, here since I don't have any space. Okay, mu1 mu2. Okay, whether this is okay, 6 minus 2.7245, you will get 3.2755 and plus okay 8.7245. Right, and now based on these intervals, okay, try answer this. Okay, try answer this. Okay, you try answer this. Okay, okay, 0 is within or not within interval. Okay, is 0 is within or not within the interval. So how do we do that? Okay, this is the operation is not necessary, but if you want to understand whether 0 is within or not within the interval, you can do this range lah. Okay, you pun letak range kan, min 3.2755, ini 8.7245. okay, so where is 0? Okay, so when you take a look at this interval, 0 is here lah, di luar interval kan. So since that the conclusion is 0 is not within the interval. Okay, thus mu1 is different than mu2. So that's the explanation. Okay, so this interval ni does not necessary pun. Okay, but if you want to understand whether 0 is not within the interval, you can draw this number scale lah, okay, to make you understand. Alright, I will continue with next video. Thank you.